Civil engineer. A professional who designs, constructs, and maintains infrastructure such as roads, bridges, and buildings. The civil engineer presented a detailed plan for the new highway project. Mechanical engineer. A specialist who designs and builds machines, engines, and mechanical systems. The mechanical engineer optimized the gear system to increase the machine's efficiency. Electrical engineer. An engineer who works with electrical systems, circuits, and power generation. The electrical engineer ensured the factory's wiring met all safety regulations. Software engineer. A professional who designs, develops, and maintains software applications. The software engineer wrote clean and efficient code for the new mobile application. Structural engineer. A civil engineering professional focused on the strength and stability of structures. The structural engineer calculated the maximum load the bridge could safely carry. Environmental engineer. An engineer who develops solutions to environmental problems, such as pollution and waste management. The environmental engineer recommended a new water filtration system to reduce contaminants. Chemical engineer. A professional who applies chemistry to develop manufacturing processes and products. The chemical engineer redesigned the process to reduce toxic emissions during production. Industrial engineer. An engineer who improves complex systems and processes to increase productivity and reduce waste. The industrial engineer implemented lean manufacturing to streamline operations. Petroleum engineer. An engineer who designs methods for extracting oil and gas from deposits below the Earth's surface. The petroleum engineer developed a more efficient drilling technique for the offshore platform. Aerospace engineer. A specialist in designing and testing aircraft, spacecraft, and related systems. The aerospace engineer collaborated on the development of a new supersonic jet. Computer engineer. An engineer who works on computer hardware and software integration. The computer engineer resolved the hardware compatibility issue in the data center. Biomedical engineer. An engineer who designs medical equipment and technology for healthcare. The biomedical engineer introduced a wearable device for monitoring heart rates in real time. Geotechnical engineer. A civil engineer who analyzes soil and rock mechanics to ensure foundation stability. The geotechnical engineer conducted soil testing before the foundation was laid. Marine engineer. An engineer responsible for the design and maintenance of ships and marine equipment. The marine engineer updated the vessel's propulsion system for better fuel efficiency. Nuclear engineer. A professional working with nuclear energy systems and radiation processes. The nuclear engineer monitored the reactor's temperature to maintain a safe operating level. Network engineer. An IT professional who designs and manages computer networks. The network engineer set up a secure virtual private network, VPN, for remote workers. Systems engineer. An engineer who integrates and manages complex systems across disciplines. The systems engineer ensured all departments were aligned during the software rollout. Robotics engineer. A specialist in designing robots and automated systems. The robotics engineer programmed the robotic arm for high-precision assembly tasks. Project engineer. An engineer who manages engineering tasks within a project framework. The project engineer coordinated between the design and construction teams. Construction engineer. A professional who oversees building projects and ensures structural integrity. The construction engineer inspected the steel framework before the next phase began. Instrumentation engineer. An engineer specializing in designing and maintaining instruments and control systems. The instrumentation engineer calibrated all sensors for accurate data collection. Automation engineer. An engineer who develops systems that operate with minimal human intervention. The automation engineer improved the production line using advanced robotics. Maintenance engineer. A professional who ensures equipment and machines run efficiently. The maintenance engineer conducted a scheduled inspection to prevent downtime. Manufacturing engineer. An engineer who designs and improves manufacturing processes and tools. The manufacturing engineer introduced a new mold that reduced defects by 30%. Design engineer. A professional focused on designing parts, systems, or products. The design engineer created a 3D model for the client's custom equipment request. Mining engineer. An engineer who plans and oversees the extraction of minerals from the earth. The mining engineer proposed a safer tunnel layout for the underground operation. Quality engineer. An engineer who ensures products meet certain quality standards. The quality engineer developed a new inspection protocol for the assembly line. Test engineer. A professional who creates procedures to test products for performance and safety. The test engineer identified a critical flaw during the final inspection phase. Control systems engineer. An engineer focused on designing systems that control machines and processes. The control systems engineer adjusted the feedback loop for better system stability. Tooling engineer. An engineer who designs tools, molds, and fixtures for manufacturing. The tooling engineer redesigned the cutting tool to improve precision and reduce waste. Production engineer. An engineer who manages manufacturing operations and process efficiency. The production engineer monitored the output to maintain the plant's daily quota. Reliability engineer. A professional who ensures a product or system consistently performs its intended function. The reliability engineer ran simulations to predict possible system failures. Packaging engineer. An engineer who designs packaging that protects and preserves products. The packaging engineer created a sustainable design to reduce shipping costs. Electrical design engineer. A professional who develops electrical circuits and layouts. The electrical design engineer updated the control panel to comply with new standards. Data engineer. An IT specialist who builds systems for collecting and managing large data sets. The data engineer built a scalable pipeline for real-time data analytics. Field engineer. An engineer who works on-site to monitor installations, maintenance, or repairs. The field engineer resolved a connectivity issue during the on-site inspection. Energy engineer. An engineer who focuses on energy efficiency, renewable energy, and power systems. The energy engineer conducted an audit to improve the building's energy performance. Pipeline engineer. A specialist in designing and maintaining pipeline infrastructure for fluids and gases. The pipeline engineer evaluated corrosion risks in the high-pressure gas line. Radio frequency engineer. An engineer who works with wireless communication systems. The RF engineer optimized antenna placement to improve signal strength in remote areas. Compliance engineer. A professional who ensures that systems and products meet legal and regulatory standards. The compliance engineer reviewed the new product to ensure ISO certification requirements were met. Acoustics engineer. An engineer who works with sound and vibration in various environments. The acoustics engineer reduced echo in the auditorium using sound-absorbing materials. Safety engineer. An engineer who identifies and mitigates risks to improve workplace safety. The safety engineer updated the emergency response procedures for the lab. Mechatronics engineer. An engineer combining mechanical, electrical, and computer systems. The mechatronics engineer integrated a smart sensor into the robotic gripper. Fire protection engineer. A specialist in designing systems to prevent and control fires. The fire protection engineer ensured all sprinklers met the updated fire code. Telecommunications engineer. A professional who designs and maintains telecommunication systems. The telecommunications engineer installed fiber optic lines for high-speed internet. Transportation engineer. A civil engineer who plans and optimizes transportation systems. The transportation engineer analyzed traffic patterns to reduce congestion in the city. Urban planning engineer. An engineer who develops infrastructure and layouts for urban environments. The urban planning engineer proposed a green zone in the city's redevelopment plan. Fabrication engineer. A professional who oversees the construction of components from raw materials. The fabrication engineer reviewed the welding process for structural components. Procurement engineer. An engineer responsible for sourcing materials, tools, and services for engineering projects. The procurement engineer negotiated a better deal with the steel supplier to cut costs. Engineering workplace vocabulary. Blueprint. A detailed technical drawing or plan used for construction or manufacturing. The team reviewed the blueprint carefully before beginning the foundation work. CAD, computer-aided design. Software used to create precise drawings and technical illustrations. Engineers used CAD software to model the mechanical parts in 3D. Prototype. An early sample or model built to test a concept or process. The prototype was tested in real conditions before mass production began. Specification. A detailed description of design, materials, dimensions, and performance requirements. The supplier must meet every technical specification listed in the contract. Tolerance. The acceptable limit of variation in a physical dimension or performance. The part must be machined within a tolerance of plus or minus 0.01 millimeters to ensure proper fit. Calibration. The process of adjusting an instrument to ensure accuracy. All pressure gauges are calibrated monthly to maintain measurement precision. Efficiency. The ability to achieve maximum productivity with minimum wasted effort or resources. The new motor design significantly improved the machine's efficiency. Ergonomics. The study of designing equipment that fits human usage comfortably and effectively. The workstation was redesigned using ergonomic principles to reduce worker strain. Feasibility study. An analysis to determine if a project is practical and achievable. A feasibility study showed that constructing the bridge in this location was not cost-effective. Load bearing. Refers to components that support structural weight or pressure. This wall is load-bearing, so it cannot be removed without reinforcing the structure. Schematic. A symbolic representation of a system, often used in electrical or electronic design. The schematic diagram helped us identify the fault in the circuit board. Simulation. A model or imitation of a real process or system to analyze performance. The engineers ran a simulation to test the structural behavior under earthquake stress. Redundancy. A system feature that duplicates components to increase reliability. The power system includes redundancy to prevent total failure during outages. Compliance. Adherence to regulations, laws, or technical standards. The product was redesigned to ensure compliance with international safety codes. Diagnostics. The process of identifying faults or problems in a system. The diagnostic software detected an overheating issue in the control unit. Life cycle. The stages a product or system goes through from design to disposal. The engineer considered the entire life cycle of the battery to minimize environmental impact. Integration. The process of combining systems or components into one unified whole. Software integration took longer than expected due to compatibility issues. Retrofitting. Adding new technology to old systems or structures. The factory was retrofitted with energy-efficient lighting to reduce costs. Benchmarking. Comparing performance metrics to industry standards or competitors. Benchmarking revealed that our product had faster processing speed than rivals. Quality assurance. A systematic process to ensure that products meet specified standards. The quality assurance team inspected each component before final assembly. Root cause analysis. A method of identifying the fundamental reason for a problem. A root cause analysis revealed that the breakdown was due to a software update failure. Bill of materials. A list of all components and materials needed for manufacturing. The bill of materials must be updated to include the new wiring harness. Assembly line. A production process where a product is built in stages along a conveyor or series of workstations. The new robots improve the speed of the assembly line by 40%. Downtime. The period during which equipment is not operating or available. Unexpected downtime cost the company thousands in lost productivity. Throughput. The amount of material or items passing through a system or process. The new configuration increased throughput by 15%. Load test. A test to see how a system performs under a heavy load. The load test confirmed that the bridge could withstand the required weight. Modular design. A design approach that uses interchangeable parts or components. Modular design allows for easy upgrades and repairs. Preventive maintenance. Scheduled maintenance to prevent equipment failure. Preventive maintenance reduced the risk of unexpected breakdowns. Failure mode and effects analysis. A method to identify potential failures and their impact. Failure mode and effects analysis helped prioritize which parts needed design reinforcement. Gantt chart. A visual project management tool showing tasks over time. The Gantt chart outlined all deadlines and deliverables for the bridge project. Lean manufacturing. A method focused on minimizing waste while maximizing productivity. Lean manufacturing principles help reduce material waste in the factory. Just-in-time. A strategy that reduces inventory costs by receiving goods only when needed. The just-in-time system improved cash flow and reduced storage requirements. Torque. A measure of rotational force. The torque wrench was used to tighten the bolt to the specified value. Vibration analysis. A technique used to monitor and diagnose equipment based on vibration data. Vibration analysis revealed imbalance in the rotating shaft. Thermal expansion. The increase in volume of materials due to heat. The design compensated for thermal expansion in the metal beams. Shear stress. A force that causes parts of a material to slide past each other. The beam was reinforced to resist shear stress caused by lateral loads. Fatigue. Failure. Failure of a material due to repeated stress over time. The metal component was redesigned to prevent fatigue failure after prolonged use. Hydraulics. The use of pressurized fluid to power mechanical systems. The hydraulic system lifted the heavy platform smoothly and efficiently. Pneumatics. The use of compressed air to operate machinery. Pneumatics is commonly used in automated packaging equipment. Load factor. A measure of average power use compared to peak demand. A high load factor indicates efficient energy consumption. Crane capacity. The maximum weight a crane can safely lift. We had to rent a larger crane due to the limited capacity of our in-house equipment.